Hello and welcome to Chapter 2 of Med Math. We're going to be talking about fractions. So here's our fraction. This represents 4 pieces, which is our denominator, and the numerator has one shaded piece. So the shaded piece is 1/4. Remember the numerator over the denominator. So this is always the total number of pieces of the whole, and this is how many you have. So here, this is in mixed number. We have our whole number and our fractional piece, and we're going to change it into an improper fraction, meaning we won't have a whole number. It'll just be one fraction. So to do that, we take 7 times 4 and add the 1. So we have 29 pieces over 4 pieces. Doing the same thing here, 16 times 1 is 16 plus 11. We have 27 over 16. And here 7 times 3 is 21, plus our 5 gives us our 26 over our 7. Right as a mixed number, here we have our improper fraction, and we're going to turn it into our mixed number. To do that, I say 19 goes into 20 how many times? Once, with 1 left over. 3 goes into 17. How many times? 5. 3 times 5 is 15. So 15 to 17, I have 2 left over. And to check to make sure I'm right, I can do 3 times 5 plus 2 gives me 17 over 3. So an improper fraction is when your numerator is larger than or equal to your denominator. So 6 goes into 33 5 times. 5 times 6 is 30. 33 minus 30 gives me 3 over 6. Now I wouldn't want to leave it as 3/6. I'd want to reduce that. So when I reduce it, 3 goes into 3 once, 3 goes into 6 twice. So my answer would be 5 1/2. 15 goes into 60 just 4 times. So when we have a number like this with no fraction next to it, we call that an integer. So sometimes they'll ask you for an integer or an improper fraction or an integer and a mixed number. So what they're asking you is, if you don't get a fractional piece, just write the whole number part. And they're basically telling you not to put it as a decimal. Factors. List the factors of 72. So what a factor is it's asking you what numbers can be multiplied to give you 72. I'm going to start at 1. 1 and 72 make 72. I know that 2 goes into 72. So 2 times 36 are factors of 72. 3 goes into 72. 3 times 24. 4 goes into 72. 4 times 18. Those are both factors. 5 would not go into 72. 6 goes into 72. 6 times 12. So 12 is a factor. 8 goes into 72. 9 times. So those are all factors of 72. The factors of 34, I'm going to start with my 1 in 34. 2 goes into 34. So 2 and 17 are also factors. Here we have a definition for prime. The definition of prime is we can only has factors of 1 and itself. Composite other factors besides 1 and itself. Neither prime nor composite would be 0, 1. 1 is said to be our unit. Prime factorization is where we take it down into the prime number. And no matter how you start with a prime factorization, it will always come down to the same answer. The only way you can get this wrong is if you mess up your multiplication or if you don't take it all the way down to a prime number. So let's go back to this. What are examples of prime numbers? 2, 3, 5, 7. Composite numbers, examples would be 4, 9, 15. So in my prime factorization, all my numbers should be 2, 3, 5, 7s, 11s, 13s. So I'm going to start at 72 with 9 times 8. Are either of those numbers prime? No, they're not. So 9 is 3 times 3, and 3 is prime, so I'm going to circle it. 8 is 4 times 2. 2 is prime, so I'm going to circle it. 4 breaks down to 2 and 2. So the prime factorization of 72 written in exponential form would be 2 to the third, 1, 2, 3, times 3 squared, 3 times 3. Prime factorization of 48. Again, you can start with any two numbers. I'm going to start with 4 times 12. 4 is broken down to 2 times 2. 12 can be broken down to 4 times 3. I further break down 4 to 2 times 2. So my prime factorization of 48 is 2 to the 4th times 3. The prime factorization of 99, I'm going to start with 9 times 11. 9 is not prime, but 11 is. And this breaks down to 3 times 3. So my prime factorization of 99 in exponential form is 3 squared times 11. Now we're going to write these in lowest terms. So you can divide by the highest number, or I see these are both even numbers, so I'm just going to divide by 2. 42 divided by 2 gives me 21. 224 divided by 2, 2 goes into 2 once, 2 goes into 2 once, 2 goes into 4 twice. Now I know the only factors of 21 are 7 and 3, so I check to see if this is divisible by 3. It is not. I check to see if it is divisible by 7. It is. 7 goes into 21 3 times, and 7 goes 1. This becomes a 7. And I get 42, so 16. So in lowest terms, this is 3/16. Here I can cancel out my zeros because I'm reducing by 10. So now I'm left with 7 over 56. Since 7 is prime, I just have to worry if 56 is a factor, or if 7 goes into 56, which it does. 7 goes into 7 once. 7 goes into 56 8 times. So written in lowest form, we have 1 over 8. For my zeros, for every 0 in the numerator, I can cancel out into 0 in the denominator. So I'm left with 2 over 4. 2 goes into 2 once, 2 goes into 4 twice. So my lowest term is 1/2. They want us to do the prime factorization and then reduce. So I'm going to do the prime factorization over here. So my prime factorization of 40 is 2 times 2 times 2 times 5. And my prime factorization of 105 is 5 times 21. So 3 times 5 times 7. Since I'm multiplying, I can cancel the 5s. 2 times 2 times 2, there's no other common factors. So 2 times 2 times 2 is 8. 3 times 7 is 21. That is in lowest form. Are these equivalent? The easiest way I know to find if they are equivalent is to reduce them. So 24 over 32. 8 goes into 24 3 times. 8 goes into 32 4 times. Now I'm going to reduce 12 over 16. 4 goes into both of them. 4 goes into 12 3 times. 4 goes into 16 4 times. Since 3/4 equals 3/4, these fractions are equivalent. So now we need to multiply the fractions and put them in lowest terms. So when I'm multiplying a fraction, I can cross cancel numerator to denominator, but I cannot cancel numerator to numerator or denominator to denominator. So 3 goes into 3 once, 3 goes into 3 once. Now I can multiply. 1 times 1 is 1. 1 times 8 is 8. You can multiply across first and then reduce. I prefer to reduce first because I'm working with lower numbers. 4 goes into 4 once, 4 goes into 12 3 times. 1 times 1 gives me 1. 3 times 5 gives me 15. 2 is 2 over 1. 2 goes into 2 once, 2 goes into 4 twice. 1 times 1 is 1. 1 times 2 is 2. Twelve is 12 over 1. 5 goes into 5 once, 5 goes into 10 twice. Now I can cancel the 2 with either the 4 or the 12. It doesn't matter. I canceled it out with the 12 because I like working with smaller numbers. So I have 6 times 1 times 4, which gives me 24. 1 times 7 times 1 gives me 7. This is an improper fraction. Most of the time we want it as a mixed number. 7 goes into 24 3 times with 3 left over. So I'm going to put this as an improper fraction. 2 times 2 is 4, plus 1 is 5. It's easier to work with a mixed number when you're adding, subtracting, multiplying, or dividing fractions. Now I can choose go into 2 one time, 5s go into 5s one time. 1 times 1 is 1, 1 times 1 is 1, 1 over 1 is the same thing as 1. So again, I'm going to make this an improper fraction. 10 over 9 times 8 over 11. I can't reduce anything, so this becomes 80 over 99. Here we have a rectangular area, 2/5 by 4 miles. And we want to know the area. Area equals length times width. So I'm doing 4 over 1 times 2 over 5. 4 times 2 is 8. 1 times 5 is 5. Improper fraction. 5 goes into 8 one time with 3 left over. As a mixed number, my answer is 1 3/5 miles. Here I'm finding out which is larger, 3/8 by 1/8. I'm finding the area, so I'm multiplying them. Length times width, 3 times 1 is 3, 8 times 8 is 64, or 1/16 times 3/4. 1 times 3 is 3, 16 times 4 is 64. So 3 over 64 is the same as 3 over 64, so they are equal. And that ends part 1 of chapter 2.